Hello everyone, welcome to the course on electromagnetic theory and interference. In this session, let us see how to solve a problem based on transmission line equations. We have been given a generator of 1 volt 1 kilohertz which is supplying a power to 100 kilometer long line terminated in characteristic impedance Z0, and they have the following constants R, L, G and C. We are asked to find the characteristic impedance Z0, attenuation alpha, phase constant beta, and wavelength lambda, as well as the velocity v. Characteristic impedance is given by this relation, which is equal to root of r plus j omega l divided by g plus j omega c. All the parameters are given except omega. Omega we know that is equal to 2 pi f, and from the given frequency of 1 kilohertz we can find the angular frequency omega in radians per second. We are going to just substitute all the values, and after simplifying, we are not able to divide the complex numbers directly within a root, so we have to convert the complex form from the rectangular to the polar coordinates, that is a plus jb format. We are going to convert to ra angle theta. So this can be done using a calculator by keeping in a complex mode, and after finding the magnitude and angle, uh, to find the answer with the root, we can directly divide these magnitude, but phase part we have to subtract the numerator angle, that is numerator angle minus the denominator angle, and after subtracting, to take out of the square root, we have to divide it by 2. Okay, and this is the answer for characteristic impedance in terms of ohms. Next, we can find the attenuation and phase constant by finding the propagation constant gamma, which is equal to root of r plus j omega l into g plus j omega c. That is going to be equal to whatever answer we got in polar form in the previous step. Here in form of fraction, we are going to just write in terms of multiplication based on this formula. And here the numbers magnitude can be multiplied directly, but angle part we have to add it. Here we subtracted, right? Here we have to add it, and for taking outside the root we have to divide it by 2. And to get the attenuation and phase constant, we have to again convert back the polar form to rectangular coordinate. So here the attenuation is the real part of the propagation constant, and we have to represent by nepers per kilometer, since all the parameters are given per kilometer. And whatever answer we get directly, it is in this form. Okay. If they ask in decibels per kilometer, we can do it based on the conversions we have already known. And the phase constant is the imaginary part of the propagation constant, so we have to take this imaginary part and write radians per kilometer. For finding the wavelength, we know the formula, it is equal to 2 pi by beta. Beta just now we have found here, but just substitute and find the answer in terms of kilometer. Velocity is omega by beta. Omega is 2 pi f divided by the same beta. We get the answer in kilometer per second. So by using the given primary constants RL, GC, we are able to find the secondary constants of the transmission line Z0 and the propagation constant gamma, from where we are able to find attenuation and phase constants. Hope you enjoyed the session. Thank you, everyone.